so our notes are going to cover the first two sections of trig. I have up here some symbols. Um, this symbol represents the Greek letter alpha. This symbol represents the Greek letter beta. And this symbol represents the Greek letter theta. We often use these to represent angles when we do trig, so keep that in mind. You can pause the screen if you want to. I'm going to the next screen. Okay, now trigonometry comes from the basis of similar triangles have proportional sides and congruent angles. If you see my diagram up here, there is an angle which we are going to call theta that is in this position here. But as these triangles get consecutively or proportionally bigger, you can see these triangles, that angle does not change. So the sides of these triangles will all be proportional, but the angles of this triangle will be congruent. And you can see I have the Greek letter beta up here as well. So we have to understand that triangles are similar. That means their angles are congruent and their sides are proportional. And this gives us the basis to when we can do trigonometry. Now, it is one of the best methods of indirect measurement we have, and we will get on how to indirectly measure as we go on with the lessons in chapter 5. So basically, your initial side is fixed, and keep that in mind. We have to know where to start. So our initial side, let's say it's the positive side of the x-axis. Your terminal side is where your angle stops. The angle measure is from the initial side to the terminal side, and that will be your angle. Oftentimes, your vertex will be at the origin. If it's on a coordinate plane, it has to. Trig is a function of the angle. If I say sine theta, if I say cosine theta, it's a function of the angle. This is a sin, okay? That's not trig. It has to have an angle in order to be called sine theta. Now, when we start rotations, here's a couple of examples. Here's an example of a positive angle and a negative angle. First off, on this positive angle, 45 degrees, initial side, terminal side, angle is measured from 0. This is 90 over here. This would be 180, and this would be 270, and it would be back to 360, and we would keep on spinning. Okay, so when we think of this type of rotation, is counter clockwise. Counterclockwise is positive for us. Over here, our initial side is there. Our terminal side is here. Our rotation is clockwise. So clockwise, we consider to be a negative movement. Okay? So that means that this is 0, this is negative 90, this is negative 180, this is negative 270, and this would be negative 360, and then yours is rotating around and around. So you have to imagine that. Clockwise rotation, negative, counterclockwise rotation, positive. Pause if you need to. I'm going to the next screen. Standard position, an angle is in standard position when its vertex is on the origin and its initial side is on the positive x-axis. So the most common angles we use in trig are your quadrangle angles. Okay, so we have 90-degree angle, we have the 180-degree angle, we have 360, we also have 270. These are all known as our quadrantal angles. Now, we have to get used to counting our quadrants. This is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. If you forget, draw the letter C, and the rotation of the letter C is how you number the quadrants. And you can say, see how easy that is? And you can move on. Pause if you need to. I'm going to the next script. Two angles in standard position with the same terminal side are called coterminal angles. They are always 360 degrees apart. Name a positive and a negative angle that is coterminal with negative 47 degrees. Well, first off, where would negative 47? I had to draw negative 47. I would say it's somewhere down here. Negative 47 degrees. Okay. Now, I need to name a positive and a negative angle coterminal with that. So I'm going to need to add 360 or subtract 360 from a negative 47. So I'm going to say a negative 47 plus 360 gives me 313 degrees. Okay. And I'm going to say a negative 47 minus 360 is a negative 407 degrees. So both of these angles are coterminal. With negative 47. Now, if I ask you this question and you give me negative 47, that's incorrect. It can't be the same angle. It has to have 360 degree movement. Now, there are an infinite number of positive angles. There's an infinite number of negative angles. So make sure you stick close to finding the basic angles around them. Don't give me something way out there. Pause if you need to. I'm going to the next script. Okay, you try this one. Negative 423 degrees. Find one positive coterminal angle. Find one negative coterminal angle. Sometimes you have to add or subtract 360 more than once to get there. Keep that in mind. So I subtract 360. Hey, there's a positive coterminal angle. 423 minus 360 gives me 63 degrees. That is coterminal with 423. I can also subtract 360 to get a negative, and that's a negative 297. So let's keep on trucking. 63 degrees minus 360 degrees is 297 degrees. So I already have two answers. Now I could have also added 360 to give me 783. So you got to keep in mind, as long as there's some type of 360 degree addition or subtraction, they will be accepted to be correct. Just don't get crazy. So this is my negative answer, and either one of these could have been my positive answer. Pause if you need to. Negative 500, again, you try it. Find one negative, find one positive. Positive, give it a shot. Okay, and we're back. So I'm going to add 360 or subtract 360. I'm sorry, I get negative 500 minus 360. Now this is an angle here, but I'm going more negative. I could have found a negative along the way. I could have just added 360. And see, me adding 360, I'm not saying it's better. It's just getting me closer to my positive result. Okay, because now I can add 360 to that, and I have my positive answer here, and I have either or these two negative coterminal angles. Okay? But on a quiz or a test, I'll ask you for one positive and one negative. You only have to give me one of each. Pause if you need to. I'm going to the next group. Now, since there are an infinite number of angles that we can give that are coterminal, we tend to write some type of expression, okay, to display that infinite basis. So give all angles that are coterminal with 75 degrees. So 75 plus 360 n is a non-zero integer. Okay, you have to say this. Okay, Because if I don't, then what if I said n was, or if I said n was 3.5? If I said n was 3.5, that's not a complete rotation, is it? There's a partial rotation, so that will not be coterminal, so that does not work. Okay, so we have to declare n to be some type of non-zero integer. Now, z, double line z, is notation for integer. So you can say n is an element of the integers. Okay, but here we had to say it was non-zero because 0 means it's still 75, and we can include that. Now it says determine the coterminal angle that is between 0 and 360 that's coterminal with a negative 1234. Pause it a second, I got it. Okay, I'm back. I'm going to determine a coterminal angle that is between 0 and 360. You will do this a lot. Okay, now 0 and 360 is what I call the first rotation. Anything in the first rotation is very important to us. So we need to get used to finding an angle coterminal that's in the first rotation. Okay, with negative 1234, then determine which quadrant the terminal side lies in. Well, this is a point to where you're just going to take negative 1234 and plus 360, and then plus 360, and then plus 360. And plus 360. So you're going to keep on adding 360 until you get an angle between 0 and 360. So I ended up finding 206. So I had to add 360 quite a few times, didn't I? Okay, so knowing your multiples of 360 can get you there quicker. But I get 206. Now, if we think about 206, where is 206 going to be? Well, this is 0, this is 90, this is 180, and this is 270. So 206 is going to be somewhere here, isn't it? And I'm going to measure from the beginning to there. So 206 degrees. Okay. And that's going to be in which quadrant? It's going to be in quadrant 3. Okay. 206 will be in quadrant 3. Now I'm going to pause it a second to show you something. So I'm going to change screens to get there. So just hold on. Okay, I'm back. So I think you're figuring out that knowing your multiples of 360 are helpful. So here's a little list. Oftentimes, these numbers, you can add these numbers instead of adding 360, or you can subtract these numbers instead of subtracting 360, and it'll just get you to positive or to negative wherever you're at a lot quicker. So just keep that in mind. The multiples of 360 are 360, 720, 1080, 1440, 1800, and there's more. I'm just saying, if you have those sort of in your head, you can say, oh, well, I could add 1440, okay? And if we think about the problem we just had, I'm going to pull up for a minute. It was negative 1234. So negative 1234 plus 1440 got me to 206 a lot quicker. So just keep that in mind. Okay, so now we're going to determine for 1597 an angle that's between 0 and 360, and we're going to determine which quadrant it's from. So again, 1597, what multiple can I subtract? Well, probably 1440 again, probably 1440. So if I say 1597 minus 1440, it's going to give me 157 degrees. Now imagine, okay, if this is 90, this is 180, and 157 has to be somewhere over here, right? And we're only so accurate with these because we're sketching. That's 157, and you're in quadrant 2, aren't you? So basically, that's the information you're wanting to give me. Now, if we think about what was the original angle, well, the original angle basically did what? It started up here and it went 360, 720, 1080, 1440, and then it finished, didn't it? So that right there shows you all those types of rotations that happened. Okay, now what about a negative 1234? Okay, well, what about a negative 1234? If we think about it, it would have started what? It would have started here, and negative would have went negative 360, negative 720, negative 1080, and then it would have ended over here at negative 1234. But that wasn't the question, but you need to know how to draw angles negatively and draw angles positively, showing the full rotations. Keep that in mind. That's important to know how. Okay. I'll pause. Pause if you need to. I'm going to the next screen. Now, we're going to give the angle measure that is 5.5 rotations clockwise. So as soon as I see clockwise, I see negative. So clockwise is negative. Clockwise is right, negative. So I'm probably going to do a negative 5.5 times 360 to get my answer right. And I should get a negative 9. Give an angle measure that is 3.3 rotations counterclockwise, so this would be positive. So therefore we would do 3.3 times 360, and that should give us 1188. And we can just check some math here. Negative 5.5 times 360. We can say 3.3 times 360. And we can see we get our result. Pause if you need to. I'm going to the next screen. Okay, now longitude, latitude, things like this are broken up in degrees, minutes, and seconds. So this works out. There's 60 minutes in 1 degree, and the minute symbol is tick mark. And then there are 60 seconds at 1 minute, so 1 tick mark for minutes, 2 tick marks for seconds. After that, it would be decimals. But it's important to know that there are 3,600 seconds in 1 degree. You need to write that. So basically, we're going to change from decimal degrees to degrees, minutes, and seconds. So 127.58 degrees. The first thing I want to do is take the 0.58 and I'm going to multiply it by 60. So 0.58 times 60 gives me 34.8. So that's the first step. Okay. Now, the decimal that's left over, I'm going to multiply by 60 again. So I have 0.8 minutes. How many seconds is that? So I'm going to say 0.8 times 60, and that gives me 40. So put the whole part together for your new answer. You get 127 degrees, 34 minutes, and 48 seconds. Pause if you need to. I'm going to the next screen. So we have a negative 407.31 degrees. So we know it's a negative 407 degrees. We don't have to do anything with that. So you give it a shot and then unpause it for the answer. Okay, hopefully you paused it. So the answer should be 0.31 times 60 gives us the minutes. So we have 18.6 minutes. So we're going to take the 0.6 minutes and times it by 60 again. Now tell us how many seconds we have. So we should end up with a negative 407 degrees, 18 minutes, and 36 seconds. Going the other way. Okay, we're going to change from degrees, minutes, and seconds to decimal degrees. We're going to change from degrees, minutes, and seconds to decimal degrees. I'm going to give you a problem. 14 degrees, 3 minutes, 17 seconds. Okay. Now remember, this is based off degrees here. So we can take the 3 minutes and divide it by 60, but the 17, how many seconds are in 1 degree? 3,600. So we're going to need to know that. So 14 plus 3 over 60 plus 17 over 3,600. So I put 14 plus 3 over 60 plus 17 over 3,600. I'm going to hit enter. So I'm going to give me some crazy fraction. So I'm going to convert this to a decimal. So I'm going to say math, and then we'll pick number 2. And there we go, 14.054. 14.055 degrees. Pause if you need to. I moved too quick. Okay, now anytime there is a negative degree, we have to distribute the negative. So this is a negative, the whole thing is negative. So a negative 150 degrees, 24 minutes, 38 seconds. So the negative has to be distributed through the entire process. So anytime you see a negative, group the entire problem in parentheses and have the negative on the outside and then distribute. So that means this will change to a minus and change to a minus. So as we type that in the calculator, we're going to say negative parentheses 150 plus 24 over 60 plus 38 over 36. And then we're going to set to convert to a decimal, that's math 2. We get a negative 150.1.411. You could say negative 150.411 degrees also. Okay, pause if you need to. And move to the next screen. Okay, reference angles. Okay, so a reference angle is an acute angle formed by the terminal side of the given angle and the x-axis. Okay, so there's something you're going to want to write down. Oh, hold on a second. So we don't show everything. Everything in trig references the x-axis. Okay, we always want to reference the x-axis. Everything in trig references the x-axis. So first we have to find the first positive rotation angle that's coterminal with the given angle. So we're going to start off by saying 516 minus 360. That gives us 156. Okay, so now we are going to take 156 and we are going to graph it. Okay, and its reference angle is between the terminal side and the x-axis. So if we notice here, the terminal side is 156, is in the second quadrant, and the x-axis is 180. So we're going to say 180 minus 156, and that's going to give us 24 degrees. So 24 degrees is equal to our reference angle. We use a calculator R for our reference angle. So let's go through this again. Okay, a reference angle is an acute angle formed by the terminal side of a given angle and the x-axis. So remember, it's always with the terminal side of the given angle and the x-axis. Remember, acute is a positive angle less than 90 degrees. So we find our angle in our first rotation, which is 516 minus 360 is 156. That's a quadrant 2 angle. Always know where you're at. Okay, so in the quadrant angle, we need to find our reference angle. So that's going to be 180 minus 156. That's equal to 20 degrees. Pause if you need to. I'm going to the next one. Okay, 1052. 1052. So we're going to say minus 360. We'll say minus 360. 332 is between 0 and 360, so that's going to be what we need. So we are going to subtract 360 twice. We get 332. We should know that this is a Q4 angle. Okay, so we have to compare it to the x-axis. So when we draw this, 332 to 360 is where R lives. So our reference angle is in there. So we're going to say 360 minus 332. So R equals 360 minus 332. And that should be 28 degrees. And again, it's got to be positive. It has to be less than 90 for your reference angle. Positive, you need to. Okay, try a negative 1013. You try to find its reference angle. Okay, so negative 1013, we're going to add 360 to that until we get something positive. So we had to plus 360 3 times. So that gave us 67. Well, what do you know? 67 is in the first quadrant, isn't it? Okay, so it's a first quadrant angle, so 67 in the first quadrant. Okay, well, 67 minus 0 is 67. So our reference angle here is just simply 67 degrees. Pause if you need to. I'm going to the next one. Okay, we're going to do a negative 1240. You go ahead and try to figure it out and come back. Okay, so a negative 1240. Let's say we're doing a negative 1240. I could probably add 1440 to that. That gives me 200 degrees. That sounds like that's quadrant 3, right? It sounds like it's quadrant 3. Okay, so now 200 is bigger than 180. I need this to be positive. So I'm going to say 200 minus 180. Okay, so in this case, R is equal to 20. Okay, so 200 minus 180 gives us R is equal to 20. So I have a diagram over here for you where theta is the angle and R is the reference angle, and this is formulas you can use for each quadrant depending on where your terminal side lies. So if your terminal side lies in the first quadrant, your reference angle is equal to the angle. If your terminal side lands in the second quadrant, your reference angle is equal to 180 minus the angle. If your terminal side lands in the third quadrant, your reference angle is equal to the angle minus 180. And if your terminal side lands in the fourth quadrant, your reference angle is equal to 360 minus theta. Pause if you need to. I'll move into the next slide. My next slide takes us to section 5.2. Since the video is already 30 minutes long, I'm just going to do section 5.1 for this video. So that's it.